Uh, Thank you, folks. Thank you, folks, for joining this talk. So, who am I? My name is Kiran. As a day job, I work as a threat hunter. My experience heavily relies upon the blue teaming work. Been in incident response and also worked in threat intelligence. And early days, I was part of SOC as well. So, I'm a first-time speaker. So, disclaimer time. Views does not represent employees, the current and the previous ones. All tools shown here are already known to the public, and please don't use it for bad purpose. These are all education purpose only. No zero-day drops today. All right, let's quickly cover the agenda. We'll try to talk about the entire ID attack surface, and we'll touch upon token-based attacks, and we'll try to look at the logging differences, and we'll finally collect all the things and finish it with how we can hunt through all these processes. Why cloud? Initially, the question of why. So almost like around 97% of Fortune 500 use Azure or Entra ID in some way of the other. Around like 70% cloud attack has been increased from 2020. Around like 40% of attacks are related to misconfiguration or human related errors. It's hard to work on cloud. It's hard to maintain cloud, and it's very hard to secure cloud. So let's take a look at the first attack that we are talking today, password spray. Most of them know password sprays, but think of it like very similar to brute force, where you have an attacker trying to guess passwords on thousands of accounts using a single password on the many accounts. This way, he does not get himself locked out, but this attack is very slow and low, attacker does not trigger any signals to the defense or the blue team who are monitoring these attacks. How anyone can do this password spray is like first you gotta know the username of the Azure or Entra ID tenant that you're looking at. So enumerating username is not a vulnerability right now as per the standards, but when you combine the enumeration of username vulnerabilities with the password that are leaked online, you can easily do a password spray on any tenant that you have. So one interesting tool that we can rely upon for password spraying is like MSOL, and there is another tool uh, have been using this quite long time. It's like OneDrive user enumeration. These tools are super heavy and super awesome. They will try to provide you a lot more information, like you just know a company or a tenant. You need to perform some kind of enumeration on those tenants. You'll get all the valid usernames. You can also enumerate if those accounts have MFA enabled or what is the status of the accounts right now. There was an interesting research done by NYX Geek. I think it was in Black Hat. He presented this talk. He was trying to enumerate all the public Entra ID tenants. He was able to enumerate around 24 million valid usernames in just a matter of 550 days. His average rate was around like 43K usernames per day. So with this amount of enumeration possible in Entra ID, anyone can combine these two tools and try to log in their way into Entra ID accounts. So where can we look for these logs? Unfortunately, not all logs show up in your environment. Most of the enumeration activity that you see and the tools that you use will not appear in these logs. Who all uses password spray? Almost all attackers and heavy APT groups also use it. Very favorite APT group is like Peach Sandstorm, using this to log in to attain initial access into customers. So these are like low and slow and silent methods. Imagine like if you have a password spray successful, not always you'll get an access to the resources. Sometimes the customers or the company will have good conditional access policy enabled from their end to prevent these kinds of attack. But there is always this guest user with no MFA and some level of access to a corp network or a demo environment. Those are the favorite targets for attackers. They will always try to find those weak areas and weak spots and try to have initial access and to get into the networks. Okay, let's take a look at token working. I think tokens 101 is like how do you get token from IDP provider? So when a client requests a token to a server, there is the authorization server will try to look at the client request and check if it is valid and provides it with access token. An access token is like a time-bound token, and this token will be in turn given to the resource. This resource could be anything: your application, website, or your custom code that you run in your servers. It gets access to this resource, and then there is a response sent back to the client. So this is how the token flow works in most of the IDP providers. Uh, we'll look at a few types of tokens here. Session tokens, these are like browser-based application use session tokens. These session tokens are typically stored as cookie. Imagine in your IR scenario and you want to revoke these tokens. Unfortunately, most of the session tokens are not recoverable, or you cannot revoke these tokens. So other type of token is like access token. Access tokens are very short-lived. I think it's for an hour. It will grant access to your applications and your protected resource. You can use service principal as well. Uh, Another type of token is like refresh token. These refresh tokens are used to obtain new access tokens without requiring an user to interact, or this helps to enable seamless authentication into your applications. Most common validity time is for like 90 days time period is for refresh tokens. So let's take a look at a very common attack path of token theft. You have a user who visits some malicious sites or have a bad malware in their system. It tries to steal their tokens, and these tokens are in turn replied into legitimate websites and your corporate assets, and they will have the full access that you uh, have as a legitimate user. So how can we protect against from this attack? There is something called as token protection in Entra ID. These are settings that you can enable in your tenant, and it tries to build up some level of protection against these token theft attacks. Few examples, what does this token protection enables is like it tries to bind your token to the cryptographic keys in your device, so that when someone try to replace, it doesn't match and it's try to return out an error. So basically, this token protection binds your token towards the device that you have, the corporate device that you have, and whenever someone is having a valid token as well, if they try to replay it somewhere else, they cannot successfully replay it since it does not match a signature that is combined with your device. You can have conditional access policies enabled for token-based attacks. They are super useful to prevent this token theft. uh, One more thing is like the major issue that most of them face is like if you need to enable token protection, you need to have a valid or a compliant device. You need to get registered yourself into Entra, and that device has to be compliant with the device signing mechanism as well. So not always in every company you have a scenario where you have a compliant device per se. So moving on, we'll look at few more ways to protect tokens. There are like risky policies you can assign to specific user groups or accounts to monitor them and to alert on top of them. These are not super hard to configure. These risky policies are like sliders in your account where you can slide and say, okay, what is the risk level that you can define for this user, and if those things match, do not allow them to authenticate. These are like conditional access policies that are present in Entra itself. So obviously can restrict some ranges of IP. If your users are based out of a particular region or a geolocation, you can restrict all those sign-ins coming from those IP itself, and not allowing anyone from outside to log in. You can use something called as continuous access evaluation. These are again features in Entra that you can enable to regularly check for the tokens uh, to check if they are having any type of anomaly in them. Always there is another go where you can look at is like credential guard in Windows, where it will try to protect the token from any kind of token theft and dumping attacks. Moving on. Few indicators that will show up in your logs for tokens are like obviously there will be a change of IP, and sometimes attacker will have an user agent that is not so regular to your corporate environment, and sometimes MFA claims will remain the same. The obviously you will have sometimes anomalous token alerts triggered in your Azure Security Central as well. So we'll move on to the next attack, enterprise applications in Enter ID. So this is a whole new attack type where let's look at what is enterprise applications. So you are a company that is developing a custom code on an application, and you need to build some level of authentication into Azure. You can use Enter ID as an authentication provider, where you have your code application, and you can front end the identity part to Enter ID, so that whenever user tries to log in, it will go through the Enter ID route and then grants access to the resources sitting behind them. So what is the risk that you can imagine here? Obviously, permissions. Permissions are very dangerous and needs to be maintained regularly. Some of the dangerous permissions we have seen in few apps are like um, uh, role management, read-write directory. These permissions are obviously granted by admins, and these have a super level of access, like it can elevate themselves to a global admin. This permission is very risky, but sometimes developer tends to do over permissive application. So in order to get them working in the first place, they will try to tick on all the boxes and enable all sort of permissions in an applications. Other dangerous app role is like app role assignment read write all. This lets you grant any application permissions that you want. So basically, like you can attain any level of access to an application. So let's try to imagine a common attack scenario where you have a test or a demo tenant that you do all sort of testing, and in turn it has a connection that you into your corporate tenant. So whenever these kinds of demo tenants or test tenants are in place, they are not always super secure. These are the favorite targets of attacker. You will not obviously have all kind of security enforcement in your demo or in your non-prod environment. So whenever these kinds of applications are overly permissive applications are present in those areas, when the attacker enters into a demo tenant, it will obviously lead to a cascading effect, and someone can obviously move from the demo to the prod using this over permissive app rules. So let's move on to hunting. We'll take a look at how we can cover a few of the attacks that is discussed here. So before hunting, we'll try to look at the log flow in this diagram. So this is from Microsoft. The dotted lines that you see in this diagrams are the things that you need to configure. The top part that you see are the elements that will generate logs. Say, for example, Azure AD sign in, Azure admin activity, or you have your Office 365 activity. The bottom are the log source front end that you will be faced as a SOC analyst, or like a as an investigator in an incident response time. So you can configure this. The dotted lines represents the effort that you need to put, and make few configuration changes in order to those logs to land in the specific environment. But the straight lines are like more straightforward. They land. They don't need any configuration. They are they're there in by default as well. So we'll look at first log, that is exposure management graph. So there is this famous quote from John Lambert: "Attacker thinks in list, and defender thinks in list, and attacker thinks in graph. As long as it's true, always the attackers win." So to combat this, Microsoft came up with graph logs, exposure graph node. Actually, these imagine these as like the logs that get populated on the data of your assets. Say, for example, you have devices, you have identities, you have user groups, and you have cloud assets. They will be like tagging each thing with a specific vector, so that when you have this in some database, or like in Kusto or somewhere, you can go there and try to make meaningful relationship out of this node. I'll show you how we are doing that in a minute. So we'll take a look at first scenario where Critical user is that have access to containers or storage accounts that are either critical or have sensitive data. Imagine you have few set of critical users. They could be C-level peoples and executives, or like an active administrator, or like an Entra ID administrator. Those are like critical users. These users or some organization classify guests as a risk. Based on their risk tolerance, they can assign these critical users. When combining this critical users list with the entity or the tags that you have with the storage containers, say for example, you can label a storage container that is having sensitive or critical data. These two nodes end up in a attack graph known as X graph edges with these types of property. I'm not going to explain all the KQL here. It's available in Microsoft blog as well. So when you try to compare these two edges of the attack graph, so you can make a meaningful relationship like, okay, I have a list of critical users and I have a list of sensitive container. Can I make a connection between them and to draw a line between these two attack vectors and form a hypothesis between them? So this is one type of hunt scenario. Obviously, you can use it. Uh, let's move on to another hunt scenario where users that have access to storage account with sensitive data. Not all users in your Azure AD needs to have access to containers. Obviously, like the developers or like the people who work with those storage accounts should have access, but not everyone should have access, right? So you can have this entity relationship, try to bring these two dots together using this exposure management graph and say to form a hypothesis to run this query. So I can look at the user list and I can look the container list and to map those things back together and try to bring meaningful relations. If something bad happens in my tenant, okay, what are all the things I can do? If this user A got compromised, what extent he can move inside the network. Basically, imagine something like building a blast radius in your tenant. So let's look at last example. Last example is like SQL servers or a managed instance that is having basic authentication that have access to the key vault activity. So whenever you have some managed instances that is not having a super strong authentication mechanisms, either that could be due to your user application or like due to your business needs, you're having some kind of basic level of authentication, but in turn they have access to your key vault. This mapping can be done. So to make a meaningful picture out of this. Okay. We'll quickly move on. We're running out of time. We'll look at attack graphs. Sorry, graph activity logs. These graph activity logs are basically nothing but all the calls that is made through Graph, Microsoft Graph. We'll try to look at a few of the scenarios, how you can formulate hypothesis around hunt traps using graph activity logs. You can identify the user activities from a compromised user account in your tenant. Say, for example, user is compromised and trying to enumerate your tenant. You can use this graph activity logs to map all those activities. Obviously, few of the tools that heavily uses graph logs are like Bloodhound and AAD internals. So let's talk about the scale of the problem that you're dealing here. Azure is very huge and there are around like 400 to 300 services. Obviously, not everything cannot be properly logged and stored into SAM somewhere. So this is a big problem when it comes to logging. A few resource that most of the organization use, like storage account, key vault, and app services, those logins are not enabled by default. Someone has to log into the admin panel and try to enable those logins. So let's try to look at the retention that is separated from the logging. Entra ID treats log retention in response to the tenant type that you have. If you have P1 or a P2 license, obviously the retention will be different when comparing it. If you have a premium license, you will be having more days of log stored in it. Here is the sample of how the free versus the P2, the premium license, when compared to a few of the areas like audit logs, sign-in logs, and MFA logs. Very minimal amount of days in the free version, but when you move up the licensing, you will get more days as well. So here is another example where risky sign-ins will be for like 7 days and in free, and then enter ID P1, you have like 30 days. When you move to the P2 license, you will have like 90 days of retention. Okay, final conclusion and final words. If you need to investigate an incident, you need to have logs for those activities. So regular audit logging and posture management is very critical in Azure Enter ID. So someone has to regularly review those things. Not always you are going to end up with logs during an incident. Logging can be expensive. In the other hand, you need to plan what you are going to log and not log everything and burning out your resources. So few of the resources that I listed here are like the Microsoft blog and the thanks to all the authors that I mentioned in the slides.
Cool, Kiran. If you have a second, I do have Kiran, if you could stick around in the Discord, people might actually, I know they have questions for you in there. I do have one in Zoom, if you would care to take it.
Yeah, let me check it.
Sure. It says, can you please elaborate how to move from demo to prod tenant using service principal permissions?
Yeah, okay. So imagine you have an application that is homed inside a demo tenant, enterprise application, but you have a consent mechanism into your prod tenant. You want to test an application as a developer, you will always develop in your demo tenant. But when you are moving into production, there might not be best practices you are not following, and you directly concern the permissions that is present in your demo tenant to your prod tenant. So you are authorizing access to be granted from demo to prod. But when it comes to permissions, they still remain the same. If you allow super excessive permissions into the demo tenant itself, it's going to replicate all those permissions in your prod as well. But obviously, someone has to go on, administrator has to go and grant those things. But if there has not been proper auditing or checks done, it will pave a way for a lateral movement scenario here.
Trimarc Vision is the next evolution in the identification of security issues across all your Active Directory environments. The Trimarc Risk Score is based on real-world expertise of Trimarc's industry-leading Active Directory and Microsoft Cloud security experts. Most importantly, Trimarc Vision helps you to answer the questions facing your Active Directory security posture today, such as what risk do I have in my environment? What actionable steps can I take today, tomorrow, this week to best mitigate my risk of an attack on my Active Directory? What should I be most concerned about within my Active Directory forest where it concerns potential attack vectors? What is the current security posture of all my AD forests? Trimarc Vision, visibility at the speed of operation.